All right, welcome to our session. We're going to talk about databases to the edge with Red Hat OpenShift and Couchbase, of course. All right, let me introduce myself. My name is John Senegal. I work at Red Hat. I am a solution architect. I work with partners in the AI, ML, also in the edge IoT solution space. So we build solutions with partners with Red Hat technology and partner technologies, and we go to market with those solutions. I come to Red Hat. I've been to Red Hat 3 years. I've had over 30 years of experience with IBM prior to that, building lots of IT and IoT solutions all over the world. So I have a wealth of experience to talk about these kinds of edge kinds of applications with Couchbase and Red Hat. So for those of you who are not quite familiar with Red Hat, I'd like to level set of what Red Hat really is and who we are and what we do. So Red Hat works with thousands of open source projects. And off to the right, what you'll see is we take those thousands of projects that we are engaged with, and we basically pull those projects together in some cases to create uh, products. So we take those projects, we pull together multiple projects, we test it, we harden it, and we turn them into products, and we make them available for enterprises because we have a long-standing relationships with enterprises, and we understand what enterprises really need. So as you might think of Red Hat as just a Linux platform, but we're a lot more than just Linux. We have a whole portfolio of products across middleware, infrastructure, automation and management, and developer tools. We also provide a lot of training and consulting and certification across that entire portfolio. At our core, and what we've been for a very long time, is an open hybrid cloud company. And what that means is that we basically have three pillars that support that vision of open hybrid cloud. At the bottom, you'll see management and automation, that in order to have true hybrid cloud capabilities, you have to be able to manage and automate things across multiple clouds or in a hybrid cloud fashion. The hybrid cloud infrastructure that we have basically says that we have a cloud native infrastructure that can run on any cloud platform. And then cloud native development is really about a set of developer tools that allow you to build cloud native applications across the different clouds that we support. So we've had the vision of open cloud, open hybrid cloud for nearly 10 years, and this hasn't changed. And now we are delivering it. Now everyone does or talks about open hybrid clouds because it's the future. Enduring principles of open hybrid cloud are consistency of customer experience, flexibility of deployment across hybrid and multi-clouds, open, access to latest innovation, and risk reduction. And so in our open hybrid cloud vision, we want to be able to deliver any workload, any footprint to any location, including the edge. So let's talk about what we mean by edge computing. So what exactly is edge computing? Primarily, it's capturing, processing, and storing data close to where the data is captured, or providing data to users where and when they need it. Well, why edge computing? Cloud computing is a great innovation that has changed everything, but there are some advantages to edge computing for certain use cases for edge processing that don't have to rely on a reliable and consistent network connectivity. Imagine a submarine or an oil rig in the Gulf of Mexico or in the North Sea in Norway. Connectivity can be very iffy depending on the weather. Some critical applications really need, excuse me, some critical applications need to operate regardless of connectivity. Having localized data that is independent of a central data is important to fulfilling this requirement. Speed. Certain edge applications, speed is critical. Do we really want to send 10 minutes of video up to the cloud data farm to process 2 seconds of it? Imagine the latency and bandwidth expense for real-time data processing. There are also applications that there is no reason for the data to leave the edge. When all the required data is being captured at the edge, the decisions or insights can be made or discovered without risking putting that data on a network. Once again, sending voice or video over a wireless Wi-Fi or 5G network running on could be super expensive. Why do that when the data can be processed locally? There are tons of AI ML tools available to process this data locally. So one of the things that also is happening with edge technology is there's a convergence between IT and OT. For a long time, I have lots of experience here. For a long time, OT organizations and the IT organizations did things completely different. Like OT people had their own processes, own applications, their own hardware, how they delivered software, on the time frame they delivered software, totally different from the IT people. But there's a strong convergence of those two. And that is what's enabling this platform that we're going to talk about today to really be effective, because now we are bringing about a lot more efficiency through this convergence of these platforms. So let's talk about edge computing and what it really means. So anytime you're going to discuss edge computing, whether you know it or not, you're going to talk about this stack. So when you talk about edge computing, there has to be some data generator, whether it's a camera, a cell phone, some information in a factory, some information coming off of a car. There's going to be some type of data generator, some sensor. That data generator then needs to send that data somewhere, because the sensors and the devices that generate the data don't always have the capacity to process the data. So there's some type of hardware. Maybe that's the form of a gateway. Maybe it's directly up to the cloud servers, but there's a hardware device that's capturing this data that's coming from the generators. And then as you look up that stack, that data has to go through several layers of processing before it can get to what I call the insight. So we got raw data coming in, and there's some insight we're trying to glean from that data. And those processes and all of this stack of stuff that has to happen is what makes up an edge computing platform. So there's storage and networking, there's a platform, there's data storage and processing, there's application logic, sometimes there's model inferencing. Across this stack, though, you have to have the ability to secure this data as it's making its way across this stack with compliance and standards as well. You also have to be able to manage all of the software that's running across this stack. So how do you manage and operate all of that stuff? But also, you have to build and deploy applications and models and database schemas and all of that for this edge platform. So you need application development capabilities and all of the DevOps processes to get the data, the operations logic, the models all down to this edge platform. So let's dig into that a little bit more. So let's sort of broaden it out a little bit so we can be clear in how we talk about our session today. So we take some of those services like network and operating system and physical storage, and we do software defined versions of all of those. Software defined platform, networking, storage, all gives us a flexibility to have a common platform that can run all across the different environments that we want to run our services on. So we break up this whole stack into platform services, data services, and application services. And as you can see, they go across the breadth of this platform application development. So you have to have GetOps. How do you define the platform and the operating system and the virtual storage definition? How do you create those and define those and deploy those across all of these edge systems? How do you get the data schemas and the models and all of that down for your data services? How do you get your applications there? So as part of this presentation, we're going to talk a little bit about that and the advantages of Couchbase and Red Hat OpenShift in getting that done. But as we talk about edge computing, we have to talk about some of the complexities that have to be addressed. So we talked about why people are doing edge computing, about security and latency and those things. But we have to also talk about the challenges that is presented when you introduce edge computing. So we have to talk about scale. So when we talk about scale, we're talking about thousands to hundreds of thousands of possible devices, clusters, and nodes that are going to exist. How do you get your applications out to thousands of devices consistently? How do you manage all of those devices? How do you get your operating system at the right level? How do you get security updates out to thousands of devices? Those are challenges that you have to address when you talk about complexity of a platform at scale. What about interoperability? You got different hardware that you're going to run. Some going to have gateways of certain sizes. Others are going to have different gateways because the applications and the workloads are going to be entirely different. So how are you going to have a common, consistent platform across all of these different hardware devices is another complexity that happens. And then let's talk about applications. When you're ready to deploy your applications, if you have different operating systems, different hardware, and OT and IT hasn't converged, how do you get your developers to build applications and deploy them in a consistent way? So these are all challenges around how do you deal with the platform services that you have to address for edge applications. But it doesn't just stop with the platform services. What about the application and data services? No edge application should be dependent on internet connectivity, especially if it's a mobile application, such as a water meter reading application or remote repair system. The application needs to be able to collect, store, process data locally, but be able to synchronize that data when connectivity is available. Most edge applications are real time, such as quality control systems that run in plants. They're monitoring things on the manufacturing lines. There's very little time to make a decision about quality. There's no time for latency to request information from a cloud system in order to make a decision. Real-time data requires real-time decisions. When we say real-time, performance is everything. Let's look at security. When we start to store data locally or transmitting business critical data over a network, that can create a serious security challenge. So the application and data services part of the system have to make sure that data is secure at all times, at rest or in motion. Now, when we look at scale, just as with platform services, application and data services need to be concerned with the ability to scale out to thousands of devices. and making sure that the right applications and data are delivered to the right devices, but also making sure that the data is kept in sync with the central data store so that we can be confident that the local decisions are being made based on accurate data. So all of these challenges come with edge computing, but there are lots of tools and processes that help alleviate these issues and problems. And that's what we're going to talk about today. So let's take a look at how Red Hat helps with these platform services issues. The challenges we presented were scale, interoperability, and consistency. When doing cloud native development, Red Hat provides a set of tools that allow developers to develop edge applications once, but can deploy those applications anywhere, whether to thousands of edge devices or to virtual machines. The development and deployment methodology is the same for your backend IT applications, as well as for your edge OT applications. By providing this consolidation, we're giving developers the right tools to meet the needs of different use cases and architectures. But it doesn't stop there. These tools, Red Hat Linux and Red Hat OpenShift, running across any of these environments, edge, bare metal, VMs, public, private clouds, give SRE teams consistent operations, limiting the separation of concerns for OT and IT teams. This brings about more efficiency in lends itself to quicker delivery times of these edge-based applications. So when Red Hat looks at or thinks about edge, and so I want to make sure it's clear that everybody sort of understands what we mean when we say edge. We've basically divided edge into sort of a use case model where we've said, okay, there's a thing called the provider edge. This is things like telcos and the towers. This is things like internet service providers. These are big regional data centers. Based on that, there's certain capacities, there's certain capabilities that can reside there that can't reside at a device edge. So we've divided up into tiers. And so we have provider edge, and then we have end user premises edge. So this is devices, or I should say, these are clusters that exist close to where the data is being collected. So this might be a factory, or this might be in the store, in the Walmart store, in the Target store, or in the grocery store. It's on premises. There are devices in the store collecting data, sending it to something on premises. And then we have the device edge, which basically is a gateway device that is collecting data, connecting to sensors, and being able to process and evaluate that data without necessarily having it to send it out to a cloud or something else. So the way we address this is with multiple architectures. So what you'll see here is based on where the use case falls. Is it a provider edge? Is it an on-premises edge? Is it a device edge? So for these provider telco kinds of applications, we have the 3-node cluster for OpenShift. Typically an OpenShift deployment is 5 nodes minimal, typically. But we offer now a smaller, more compact deployment of OpenShift that has full HA capability. There's also something we call remote workers, where your control plane can run at the on-premises edge, and you can have remote workers that are running the workloads in different places at the edge where the workers are. So this is the remote worker nodes. And we also have single node deployment that allows you to actually have a full OpenShift cluster. It's non-HA, but it's a full OpenShift cluster that can actually run on some levels of gateway devices. And then finally, at the end, we have what we call a small footprint device edge. That's primarily a Red Hat Linux deployment on a small gateway, and we'll go into some detail about that. So let's talk about what that means, Red Hat Linux for the edge, right? There's some capabilities that we've added that gives you a lot more flexibility in how you build and customize your OS images. You can now build special, optimized, purpose-built OS images to meet the needs of edge-based use cases. There's also over-the-air updates for those images to address intermittent connectivity. And you also have things like stage updates on power reboot cycles that allow you to control when the system gets updated and to limit downtime. For those of you who don't know, let me dig just a little bit into OpenShift. So OpenShift is pure Kubernetes, and Kubernetes is a container management platform. It sits on top of the Red Hat Linux operating system or the RHEL and the RHEL Core OS operating system, depending on the deployment model. But also OpenShift adds a layer of other cluster services like over-the-air update, monitoring, there's an internal registry, Helm support, there's software-defined networking. So there's a whole set of cluster services that we add on top of a base Kubernetes. I won't get into the details of the other services that provide, but there's also platform services, application services, and developer service. All of that makes up the things we talk about when we talk about OpenShift. So one of the main features of OpenShift that was changed to be able to support edge deployment is autonomous operations. So now we have these stacks of software that now can, through the Kubernetes platform, can now do GitOps, can get updates on demand. So as things are developed and as things change based on the configuration, you can have autonomous operations of a system in terms of getting things updated, getting models and applications deployed. You have a common Kubernetes platform. So now most edge applications at least have two tiers. There's a part of the application running at the edge. There's a part of the application running either in some interim data center, regional data center, or in a cloud. But now with Kubernetes and OpenShift at the edge, you now have a common Kubernetes platform. So it has common tooling, a common management experience, a common experience. And you also have common management. So it's a common system across all of these environments. The edge, the VMs are in the public-private cloud. You have the same environment, the same way to manage things, the same operations. So we bring about consistency across all of those environments, therefore converging OT and IT. So we'll get into these details about the value of that. So let's talk a little bit about Couchbase. So Couchbase supports the synchronization and management of data from the edge to the cloud, or edge to edge, because there's peer-to-peer capability. It works fully disconnected and syncs when connections come available, handling all the retrial logic behind the scenes. So let's dig into the components here that make up Couchbase. So you have the Couchbase server, which is the flagship NoSQL data platform with support for a number of services, including query, analytics, FTS, and eventing. Typically, you'd have develop a web backend application using your language of choice and using the SDK that's provided by Couchbase to interact with the Couchbase server. Then you have Couchbase Lite, which is full-featured NoSQL embedded data storage for mobile and non-mobile embedded platforms. Then there's the Sync Gateway that sits between and is responsible for secure data synchronization, routing, access control between the clients and server tiers. A key characteristic of this architecture is that you can deploy this in the cloud or edge data center. You have complete control over where you deploy Couchbase server and Sync Gateway. So now we've talked about edge. We've talked about why people want to do edge technology. We talked about some of the complexities of platform services and some of the complexities of application and data services when you start to deploy edge systems. And we've also gone into Red Hat Linux and OpenShift. And we've also talked about the Couchbase technologies that try to address all of these edge complexities. So let's talk about what these technologies mean when they're combined. Like what are the platform services and data services together, and what's the value that they bring? So that's what this section is going to talk about. We're going to get into some details about architectures that are supported and the reason why these architectures make sense to solve certain problems. So let's talk about offline first applications. You have government-owned factories such as North Dakota Mill and Elevator Factory that don't have the same access to the internet as you do working from home when they are deep within the mill. When you think about offline first applications, think about enforcing the principle of least access privilege, which means that each employee can only access the bare minimum resources necessary to perform their job. Think about having in place data security policies against device loss, man-in-the-middle attacks, and other security concerns. So to address this offline first application, you would think that there is some tablet or computer that has some processing in a local database, or you might have a terminal that has data locally and processing locally and interacting with end users. And then there's some centralized database in a cloud data center. So to address this type of architecture, we would have the Couchbase Sync Gateway and the Couchbase Server. Then you would have Couchbase Lite running on the computers or tablets or on the terminal. And then between them, Couchbase Lite would connect through the Sync Gateway to synchronize data with the Couchbase Server. Basically, this can operate in a disconnected mode. When connections are available, data is then synchronized. So now you have accurate data being shared between the localized computers and terminals and the Couchbase server. But we don't stop there with just the data services. As we mentioned, you have to have a platform that runs across these thousands of terminals or hundreds of computers and tablets that can support the Couchbase Lite, and you have to have a platform that runs in the cloud that can support the Couchbase server. And now that you have a consistent, let's say, containerized application that the backend runs on the cloud that provides reporting and capabilities to the business analyst, and there's applications down on the computers and in the terminals collecting data and processing data there, both parts of those applications need to run on a common platform and access Couchbase data. So at the computers, they access the data through Couchbase Lite. On the back end, they access the data through the Couchbase server, but all running within a common Red Hat platform that gets managed through the advanced cluster manager. So whether you're talking cloud only, you're talking about 10 devices, or you're talking about thousands of devices, the Red Hat cluster manager has the ability to manage those. Let's talk about another architecture around distributed processing with data edge centers. Today, we all use smart cities. Think about traffic lights that are synchronized with emergency vehicles, allowing them to save lives, or citywide water meters looking for leaks. This is real edge computing used in major cities. Running regional data center provides localized data mart that isn't dependent on central data. This provides regional flexibility as well as easy integration into headquarters. So let's talk about this architecture. So this is a multi-tier hierarchical data center. So let's just say you have these applications that, once again, there's applications running on tablets and computers. Perhaps there's applications running on terminals, but there are regional data centers that we call provider edge that has data as well. So as part of the application, there may be some reliance on data in the regional area that's important and critical for the processing that happens on the terminal or tablets. And then at some point, that data all has to be synchronized with the central data that collects data from multiple regional data centers. So we start at the top with a Couchbase server and a sync gateway, of course. But here at the provider edge or the regional data center, we have a Couchbase server and a sync gateway as well. But these get connected to the Couchbase Lite data that's actually on the device or on the terminal. So as data is being collected here and given the internet capability or the connectivity, synchronization happens between the computers or terminals and the regional data centers. So now you go back and forth, you collect the data that you need for processing from the regional data. That data is stored locally on the terminal, and any processing that needs to happen with that data. If it's disconnected, when connectivity is restored, the data is then synchronized back up. And then at some point, this regional data center then has to replicate its data up through the sync gateway at the cloud data center. And so now all the regional data centers' data is in a centralized location that provide for other batch kind of analysis and reporting that covers all of the data that comes from all of the regions. And of course, in order to be able to operate like this, you need a platform like Red Hat OpenShift or Red Hat Linux to be able to support the application, to support Couchbase Lite, to support Couchbase Server, running these types of edge-based applications. Let's talk about a completely disconnected edge data center. Healthcare Wi-Fi is a target for ransomware, allowing doctors, nurses, et cetera, the ability to work electronically and not have to use Wi-Fi to do their job. Using handheld devices has value. What I like about using edge computing on ships is the ease to connect onboard sensors with handheld devices, even without Wi-Fi, let alone internet access. So let's talk about a multi-tier hierarchical data center with an on-prem model. So it's similar to the others, except there's data locally on-prem. So imagine a factory where there's lots of things going on, and there's on-prem data that's primarily related to this factory in its operations. So the workers in this factory may have kiosks and terminals for checking in, time cards, et cetera. Others may be walking about the plant, getting information, collecting information, displaying, reporting information, monitoring information. And others may have mobile devices where they want access to plant operation data remotely from their mobile devices, but all collecting data from the local on-premises plant. So once again, we start with a cloud data center model that has the Couchbase server and the sync gateway. We go to the regional data center. We have a server and a sync gateway, but we also have a server and a sync gateway running on-prem. And so now, like the others, we have the Couchbase Lite synchronizing with the sync gateway, but we also have the ability to have these sync gateways replicate with each other all the way to the main cloud data center. But another feature of Couchbase Lite is being able to, I need to go back, is synchronize across these devices. So Couchbase Lite has a peer-to-peer capability that allows you to synchronize data from these small devices to the computers to the terminals, which is a very powerful feature in a disconnected model for an operations like a plant. In this picture, you'll also see that OpenShift has ability, of course, to be that platform of choice to support this multi-tier hierarchical model. And what you'll see is on the on-prem sync gateway and Couchbase server, we have OpenShift, and I have a ROW there, meaning remote workers. So you could actually have the main control plane from OpenShift running in the regional data center, but connecting to remote workers that run on premises. So that regional OpenShift can be the control plane to make sure that all of the workloads running locally on-prem are managed from that regional data center. That's just one model. There are multiple architectural models that we can use to solve this problem. We could also run Red Hat OpenShift, the single node OpenShift, perhaps on these tablets or computers, depending on the size and model of them, or on these kiosks or terminals as well. So you have collaboration in a disconnected environment. Couchbase is the only enterprise database that can work in a disconnected environment and communicate with other devices. Think about all the existing applications that could be extended by putting Couchbase in front of their data flow. Modernizing everything from deucing lines in your cafeteria or tracking airplanes, moving at Mach speeds, are use cases that can collaborate in a disconnected environment. Every job that is done in the field is going to have a scenario where they aren't going to have internet connectivity. So we start with a similar model, but this is the peer-to-peer sync, and this is what I really wanted to talk about. And I talked about it on the previous slide, but this was the slide I was really trying to get to. So this model is very similar to the others, but as you can see, the Couchbase Lite peer-to-peer sync here allows that communication between all of these on-prem devices so that you don't have to have connectivity between the on-prem or device edge in the regional data center. You can get data from each one of these other devices through the peer-to-peer sync. So a scenario where the Couchbase Lite from the terminal had access to the regional data center and was able to collect data, that data can then be synchronized with the other computers and the other devices that are operating on-prem. And of course, once again, we have OpenShift and Red Hat Linux and the Advanced Cluster Manager as a platform service to be able to support this architectural peer-to-peer model that we're showing here. So let me give you some examples of these technologies in action. So all of that was all theoretical, all examples of great architectures that we know work, but let's talk about it actually in the field working. So here what you see is an Italian water company that basically provides regional kiosks, probably I think around 60 or 70 kiosks around certain regions of Italy, where customers can go and get still and processed water from these kiosks. And they can also monitor the quality of the water. They can get other information from the water company at these regionalized kiosk systems. And so what they wanted to do was to have a container management platform running on these kiosks that basically allowed them a common way of building applications that could be easily deployed out to these kiosks, these 69 kiosks across that region of Italy, but also use the same technology to build a backend application that processes all the water quality data, that provides the data to their customers. And they also wanted a vehicle to be able to communicate openly with their customers about what's going on, water quality, weather, other information at these local kiosk areas. So that's an example of a utility taking advantage of these microservices and containerized IoT services that Red Hat supports. Here we have emergency responders. The Zulu emergency app that was built with Couchbase allows real-time context sharing and has Couchbase Lite on it, running on a ruggedized system that runs in a totally disconnected mode and allow people to monitor the vitals of their patients, but also connect and share that information with the emergency hospital that they're delivering those patients to. So these are just two examples. I didn't want to put too many in here of scenarios where these kinds of technologies are in action in the field today, solving real world problems. And so together, Couchbase and Red Hat OpenShift and Red Hat Linux basically give you the necessary platform services and data services to solve a large portion of the issues you're going to have building out edge applications. And so as you think about the problems you have and the challenges you have building out these applications, consider these tools who work well together. Couchbase and Red Hat are great partners, been partners for a long time. We do a lot of things together. We have a lot of joint customers. So if you have questions, please contact a Red Hat representative or a Couchbase representative, and we can follow up with you and have conversations, more detailed conversations about the problem you're trying to solve and how we can help you solve it. I want to thank you for taking your time to join me in this session. I hope it was a valuable use of your time. I hope you continue to enjoy the conference and have a good day. Thank you very much.